Hi everyone, welcome to Trigonometry. Today we explore lesson 1, angles and the 6 trigonometric functions. Number 1, angles. Definition: an angle is the space measured in degree or radian of the intersection between two lines or surfaces. One line, another line, the intersection point. So this would be the angle theta. We want to put the angle theta on the XY plane. So here come the XY plane. And let's say that we have another line or a vector. Go like this, then this would be the angle theta. Say theta. We go down in the opposite direction. We have negative of that angle. One full cycle is 360 degrees. So if we go for the one full cycle, that is 360 degrees. Well, from here, we can divide this out evenly. A right triangle is 90 degrees. So this is 90 degrees, 180 degrees, 270 degrees. And sometimes it is best to write angle in radian for ease of computation and used in advanced math courses. Radian, you can see this as a multiple of pi. Where pi is 180 degrees. So 180 is equal pi. 90 degrees is pi over 2. 270 degrees is 3 pi over 2. And 360 degrees is 2 pi. One cycle is exactly 2 pi. And since we divide the XY plane in 4 different quadrants, we call this space quadrant 1, quadrant 2, quadrant 3, quadrant 4. Let's take a look at some example on how we play around with the angles. Example, convert each angle in radian to degree and sketch each one. A, 2 pi over 3. Well, we know pi is 180 degrees, so it's going to be 2 times 180 degrees over 3. Well, that is 360 degrees divided by 3 is 120 degrees. Now we can sketch the 120 degree angle. That is 90 degrees, 180 degrees. So 120 degrees is a little bit more than 90 degrees, something like this. It's 120 degrees or 2 pi over 3. Yay, that's cool. B. Let's take a look at negative 3 pi over 4. It's negative 3 times 180 degree over 4, which is negative 135 degree. Is x, is y. Well, negative, we would have to go backward. So 135 is between 180 and 270 is negative. You have to go, it's somewhere right here. And then if you go backward, so this would be negative 90 degree, negative 180 degree. Yay! This is the negative 135 degree, which is negative 3 pi over 4. Another example, convert the angle in degree to radian and sketch it. The angle is 330 degree. So to do this, we're going to multiply by 1. And because pi is equal to 180, so the number 1 is pi over 180. We have a 33 over 18 pi. We can simplify it to 11 over 6 pi. Okay, so where does 11 over 6 pi go to? X is y. Well, it's pretty near 2 pi. It should be somewhere right here. This is the angle theta. Let's move on to 2 reference angles and the corresponding right triangles. Definition: delta bar is the reference angle and it is adjacent to the x-axis. We have 4 different reference angles. So we have a reference angle in quadrant 1, and that look like this. So if this is the angle theta, then the reference angle is exactly the angle theta. Reference angle in quadrant 2. Well, here comes the angle theta. The reference angle is adjacent to the x-axis. So this would be the reference angle. Q3 reference angle. An angle in quadrant 3. The reference angle is adjacent to the x-axis, so this would be the reference angle. Last one, Q4 reference angle in quadrant 4. Let's say that is the angle theta right here. Then the reference angle is adjacent to the x-axis, so this would be the reference angle. Well, for each reference angle, we can sketch a right triangle. It is the right triangle. This is the right triangle. This is another one, and this is another one. The adjacent side of the right triangle is always on the x-axis. Ta-da! Pretty cool. What can we use it for? Let's take a look at some example before we do the application in the next section. Example, sketch the angle is reference angle and the corresponding triangle. Okay, sẽ come A, the angle theta is the 125 degree. 125 is more than 90, so it's going to be right here. This is the angle theta, meaning that this angle is the reference angle theta bar, and we have the corresponding right triangle. Very cool. B, the angle theta is 4 pi over 3. Let's take a look at the sketch. No need to convert it to degree. 4 pi over 3 is more than pi, but it's less than 3 pi over 2. So it's going to be somewhere right here. This is the angle theta. So the reference angle is this one. And we have the corresponding right triangle. Pretty cool. Okay. Let's say that they are asked a question. What would be the reference angle in example A? So according to the sketch right here, the reference angle is, it looks like it's 180 degree minus the angle theta, which is 180 degree minus 125 degree, and that is 55 degree. And in B, based on the corresponding right triangle, then the reference angle is the angle theta minus pi. So that would be a 4 pi over 3 minus pi. The sixth trigonometric functions. Remember, the corresponding right triangle is just a right triangle. So let's take the right triangle in the first quadrant. Here come a nice right triangle. Well, we have the angle theta. The opposite is OPP. Adjacent, ADJ. Hypotenuse, HYP. Here comes the definition of sine of the angle. Sine of theta is written as sine theta, and that is opposite over hypotenuse. Cosine of theta is cosine theta, adjacent over hypotenuse. Tangent of the angle theta is tangent theta. And the definition of tangent is opposite over adjacent. Or you can see it is sine theta over cosine theta. A nice identity. We have cotangent of the angle theta, which is 1 over tangent theta, and that is adjacent over opposite. You can see this as the identity cosine theta over sine theta. And cotangent theta is written as cotangent theta, COT theta. We also have a secant of the angle theta. It's defined as 1 over cosine of the angle theta, and that is hypotenuse over adjacent. Secant is written as secant of the angle theta. One more, because we need to sit up there. Cosecant of the angle theta is 1 over sine theta, and that would be hypotenuse over opposite. Cosecant is written as CSC of the angle theta. And there you go. These are the 6 trigonometric functions defined using the right triangle. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I'll see you in the next video.